Welcome to Lesson 3 on branched hydrocarbons. Our lesson objectives: determine the name of branched hydrocarbons. A branched hydrocarbon is simply just that, where there's a branch of carbon sticking off a main chain of carbons. In order to name these branched alkanes, all single bonds, we're going to name the longest chain of carbons first, and we're using that as the parent name or last name. And we're going to name these shorter branches called alkyl groups, and we're going to specify which carbon they are sticking off of, and giving that position the lowest possible number, so we can number left to right or right to left. When we're locating the parent chain of carbons, it may not always be a complete straight line. They could be curved upwards or downwards. All of these examples are all for carbons in a row, and therefore they're all butane. When we name our branches, our alkyl groups, we're going to use table P for our prefixes. So if it's a one carbon branch, as in the example here, one carbon is meth, and we add the YL ending, indicating that it's a branch. So if it's one carbon, it's methyl, two carbons would be ethyl, three carbons would be propyl, and so on and so forth. So let's work through an example of a branched alkane. I first realize it's a branched alkane because I see this long string of carbons, and then I have these branches sticking off. And so the first step is to find the longest continuous chain of carbons. That's our parent chain. In this example, it's actually straight across. And it's 1, 2, 3, 4, 5, 6, 7 carbons. Since we have 7 carbons, table P tells us that's hept. Since these are all single bonds, this is a heptane. So our parent name, or like last name, would be heptane. Step 2 is we're going to number the carbons in the parent chain, starting with the end that will give our branches the lowest possible number. So in this case, I'm going to number from right to left, since my branches are closer to the right side than left side. If I numbered it left to right, 1, 2, 3, 4, 5, 6, my branches would be on the 4th and the 6th carbon, versus in this case, the 2nd and the 4th carbon. So again, I want to give them the lowest possible number. The next step, once I've identified my branches, and I like to circle them, so I suggest doing those in your examples, is to use table P to figure out what is the name of these branches. Well, this branch here has one carbon, so one carbon is meth, and we're going to add the YL ending for the branch, so this is a methyl group, and this is 2 carbons in a row, and so 2 carbons is eth, so this is an ethyl group. Next thing we're going to do is we're going to add numbers to the names of these groups to identify their position on the chain. Where are they located? Well, this methyl group is on the 2nd carbon, and this ethyl group is on the 4th carbon. So I put the numbers in front of the name, indicating their position. So the methyl group is on the 2nd carbon, as we said here, and the ethyl group is on the 4th carbon. And our parent name from our previous slide was heptane, because there's 7 carbons. Next thing we want to do is we want to take those branches and we want to put them in alphabetical order. So it's 4-ethyl, 2-methyl, heptane. And lastly, we're going to use punctuation. So commas will separate numbers, and hyphens will separate numbers and words. So our final name for this branched alkane is going to be 4-ethyl, 2-methyl, heptane. Notice that we have these dashes in between our numbers and our letters. Let's look at another example. The first step, I want to figure out how many carbons do I have in my parent chain. So my longest string of carbons is going to be straight across here, which is 1, 2, 3, 4, 5, 6. 6 is hex. Since these are single bonds, it's going to be hexane. That's my parent name or my last name. Then I identify my branches. I have a branch here and a branch here. And so in this case, I want to number from right to left again. So 1st carbon, 2nd carbon, 3rd, 4th, 5th, and 6th. So I have a branch sticking off the 2nd carbon and the 4th carbon here. Step 3, I want to name these branches. So I have a 1 carbon branch, that's methyl, a 1 carbon branch, that's methyl. This is on the 2nd carbon, that's on the 4th. So it's 2-methyl and 4-methyl. But we don't like to repeat the same word twice. What we can use is something like di. So we can say 2,4-dimethyl. Di meaning two methyl groups. One's on the second carbon as we have here, and one's on the fourth carbon as indicated by this number. So every branch always gets its own number, even if they're on the same branch. And so lastly, putting it all together, the name of this branch alkane is going to be 2,4-dimethyl, meaning two methyl groups on the parent chain, which is a hexane. So 2,4-dimethyl hexane. Let's look at one more example. Same as before, find the longest string of carbons in a row. In this case, it's straight across. We have 1, 2, 3, 4 carbons. 4 carbons are going to be butane. Next thing, identify our branches. These are both off the same carbon. They're both one carbon branches. So I'm going to number from left to right, giving them the lowest possible number. And so both of these branches are sticking off the second carbon. They're both one carbon branches, which are methyls. Since there are two of these things, a methyl and a methyl, we don't say methyl-methyl, we say dimethyl. And then I want to give the location of these branches. Since they're both on the second carbon, we're going to put 2, 2. Again, each branch always gets its own number location, so you know where to place them. So the final name for this is 2,2-dimethyl butane. Let's check our understanding. Can you determine the name of branched hydrocarbons? At this point, you should be able to determine the name of branched hydrocarbons.